I'm James.
I'm Hunter.
And I'm Will. And we're going to be discussing the 5 gas laws. The first one being
Boyle's Law,
Charles' Law,
Guy Lussick's Law, and Avogadro's Law.
and the ideal gas law. We're also going to be wearing
safety goggles,
no loose clothing,
with our hair pulled back,
and lab coats.
Alright, first is Boyle's Law. Boyle's Law states that the volume of a fixed mass of a gas varies inversely with the pressure and constant temperature in his equation PV equals K. Pressure equals P, volume equals V, and K is simply the constant.
For our experiment, we will be testing spray paint. Why? Before using the spray paint, you are supposed to shake the bottle. Do you hear the ball bearing rattle inside?
There are 2 substances inside the can, one your product, and the other being a gas that can be pressurized so it retains a liquid state, even when it is heated past boiling point.
The can is completely sealed, so there is no escape route from boiling and turning to a gaseous state until pushed down on the nozzle. So as soon as the nozzle is pushed down, this immediately starts boiling into a gaseous state. Instantly, the propellant expands to escape the high pressure and escapes the atmosphere where low pressure exists. The product shoots out and you have color.
Second is Charles' Law. Charles' Law states that the volume of a fixed mass of gas at a constant pressure varies directly with the temperature in kelvins.
Experiment number 2, Charles' Law.
God!
As I put the dented ping pong ball into the heated water, the temperature of the gas increases because the heat of the water is also heating the air inside of the ping pong ball.
Relating back to the law, as the temperature increases, it will take up more space. So as the air inside the ping pong ball heats up, it expands to take up more space. This makes the ball round again to keep playing. Third is Guy Lussick's Law. The Guy Lussick's Law states that for a given amount of gas held at a constant volume, the pressure is proportional to the absolute temperature. Experiment 3, the Guy Lussick's Law. In this part of the experiment, water is defying gravity and is almost sucked into the beaker as the temperature changes inside the beaker.
We have here a burning candle sitting on a lid filled with water. With the flame still burning, the air inside the glass is heated, causing high pressure, but as the beaker suffocates the flame, it goes out, pulling the water up from the air.
Avogadro's Law, V equals Kn. This law states that equal volumes of gases at the same temperature and pressure contain equal numbers of molecules.
Alright, this is experiment number 4, Avogadro's Law. Here we have a flat basketball.
In our example, we are going to pump up a flat basketball. Inflating a basketball is an example of Avogadro's Law because as more air is pumped into the tire, the volume increases, therefore the amount of moles increase.
Ideal gas law, PV equals nRT, R acting as the constant. The ideal gas law is the mathematical relationship among pressure, volume, temperature, and the number of moles of a gas.
Experiment 5, Ideal Gas Law. As the pressure increases in his mouth, volume in the balloon goes up, which is an example of the ideal gas law. Another example is fixed pressure. I'm going to take this can of compressed air and spray it on the balloon. Watch as the temperature changes, so does the volume.
Spray it!
No, as she's blowing it.
The radius
As you can tell, the radius decreased.
Overall, the 4 gas experiments in order that we used were Boyle's Law,
Charles' Law,
Guy Lussick's Law, Avogadro's Law,
Ideal Gas Law.
and the safety we used were
Safety goggles,
no loose clothing,
hair pulled back,
with our lab coats. sealed, so there is no escape route from boiling and turning into a gaseous state
Get
until
outta
pushed
here.
down on the nozzle.
Experiment number 2, Charles' Law.
Wait, is that? Do I
She's
miss
such a
it?
miss, Mom. I tried.
Guy Lessig's law states that for a given amount of
We
gas
already
out
read
of a
that, Ma.
constant.
Experiment number 2, Charles' Law.
Heated, causing high pressure.
You have to wear your safety goggles. We get it. I asked if we don't get safety goggles.
Another, James, stop. Experiment number 2.
Name the law. Name the law. Oh well, I forgot you had a phone.
Here we have a flat basketball.
Fuck, we still miss it.
Welcome to your tape.
Wait.